All right, hi everybody. This is Mrs. Snook with section 7.2, multiplying powers with the same base. And our objective is to multiply powers with the same base. So here's our first problem. It says that scientists estimate that there's about 10 to the 20 stars in the universe. And a cubic meter of beach sand contains 10 to the 9 grains of sand. Now suppose all of the sand from the world's beaches is combined into one large beach, as shown below. So if you see in this picture, this is one large beach for all of the world's beaches. Are there more stars in the universe or grains of sand on the world's beaches? So take a second and think about it. Do you think there's more stars or more grains of sand? Okay, so let's figure this out. So it's given us this picture of the beaches. And we have 1 meter deep, 100 meters wide by 100,000 kilometers long. So if I could just let me see if I can do this. Yeah, that didn't look too good. So kind of imagine that we're dividing these beaches into little boxes like this. So that's like 1 cubic meter. And we're going to have to figure out how many cubic meters there are, because every cubic meter has 10 to the 9 grains of sand. So first of all, we have stars, and there's 10 to the 20 of those. And so what that means is it's the number 1 with 20 zeros written after it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That is a huge, huge number. And so a lot of times, instead of writing these numbers all the way out like that, we'll just use 10 to the 20. Or you could think of it as 10 times 10 times 10 times 10 times 10, and there'll be 20 of them. Now for our grains of sand, I know that each cubic meter has 10 to the 9 grains of sand. And then I know I have 1 meter tall times 100 meters wide times 100,000 kilometers. And those are kilometers. And then I need to get it into meters because everything is in meters. And there are 1,000 meters in a kilometer. Sorry. Meters per kilometer. So if I string all these together, the amount of sand in each cubic meter, and then this is all figuring out the cubic meters. So let's see what we get. We get 10 to the 9 times, well, 1 times 100, that's 100, times, and here's 100,000 times another 1,000. Now I can write 100,000 like this. 1 times 10, I've got 1, 2, 3, 4, 5 zeros. And then I have a 10 to the 3. So when I go ahead and I put all this into my calculator, I get 10 to the 9. Where's my arrow? Times 100 times 10 to the 5 times 10 to the 3. And my calculator said this. It said 1e to the 19. And in calculator language, that means 1 times 10 to the 19. Now in math, I don't have to write a 1 times. So I can just say 10 to the 19. So my sand is 10 to the 19, but stars is 10 to the 20. So it looks like we're going to have a lot more stars. Okay? So let's do some multiplying of powers. That's what I was doing in our first problem here. Now let's do some that are easier. So we're going to write each expression using each base only one time. And the base is the 12, so that's the base. And the 4, that's an exponent. So when I say 12 to the 4, what that means is 12 times 12 times 12 times 12. That's 4 of them. And I'm going to multiply that times 12 to the 3. So I get 12 times 12 times 12. I got 3 of those. Well, how many 12s altogether? 1, 2, 3, 4, 5, 6, 7. So this equals 12 to the 7. Now let's do negative 5 to the negative 2 times negative 5 to the 7. Well, negative 5 to the negative 2, that's like negative 5 times negative 5. Because last time we learned that if we have a negative exponent, we move that downstairs. And I'm going to multiply that by negative 5 to the 7. So negative 5 times negative 5 times negative 5 times negative 5 times negative 5. Let's make sure I have 7 of those. 1, 2, 3, 4, 5. Oh, 2 more. Negative 5 times negative 5. And now look what happens. Some of these negative 5s cancel out. Cancel, 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 cancel. So that leaves how many left? 1, 2, 3, 4, 5. So now I have negative 5 to the 5. Let's look at something here. I had negative 5 to the negative 2 and negative 5 to the 7, and I got negative 5 to the 5. Well, what if I added negative 2 plus 7? That gives me 5. And then let's look at the first one we did. I had 12 to the 4 times 12 to the 3, and I got a 12 to the 7. Could I just add that 4 and that 3 and get 7? I think I'm seeing a pattern here. Let's do another one. We'll see if our pattern holds. I have 9 to the negative 3, so those need to move downstairs. 9 times 9 times 9. That's my 9 to the negative 3. I just took them and put them downstairs. Now let's do 9 squared. So 9 times 9, that's my 9 squared. So I've got that one, I've got that one. And then there's 9 to the 6. 9 times 9 times 9 times 9 times 9 times 9. Let's make sure I have all my 9s here. So I have 2. That's these 2. And then I have to have 6. 1, 2, 3, 4, 5, 6. And now check it out. Some of these 9s cancel. Cancel, cancel, cancel. And I'm left with how many? 1, 2, 3, 4, 5. So I'm left with 9 to the 5. Now a moment ago I was thinking I could just add those exponents together. Let's see if that works on this one too. So I have a negative 3 for my first exponent, plus 2 plus 6. So negative 3 plus 2, that's negative 1, plus 6 is 7. Negative 1 plus 6, I'm sorry, is 5. So look, and I have 9 to the 5. So there's a shortcut here that I hope you're noticing. When you're multiplying by the same base, just add the exponents. So add exponents. Okay. So now let's use that shortcut that we've worked out, and let's do some of these algebraic expressions. So I've got some numbers and I've got some variables. So I have 4 and 9. Well, they're not the same base, so I'm just going to multiply those together. So I have a 4 times a 9. And now I have z to the 5 and z to the negative 12. So that's going to be z to the 5. And I'm going to add my negative 12, which would look like that. Because if I add a negative, that's the same thing as subtracting. So I get 4 times 9, which is 36, z to the negative 7. Now I have a negative exponent, so I need to move that downstairs. I can't leave it alone. So I'm going to get 36 over z to the 7. The next one is 2a times 9b to the 4th times 3a to the square. So I'm going to look at my numbers again. I have 2 times 9 times 3. 2 times 9 times 3. And then I have an a. This is like a to the 1. It's an invisible 1. And I have another a to the 2. So I'm going to add those exponents together. I get a to the 1 plus 2. Just add my exponents. And now b, this b to the 4th is all by itself. There isn't any other b's to add to it. So it's just b to the 4th. So then I get 2 times 9 is 18. Times 3, I get a 57. A to the 3, b to the 4. Let me check that on my calculator. I did that in my head. Let's make sure I did that right. 2 times 9 times 3. 54, not 57. So that's the answer here. The last one, do your numbers. So negative 4 times 7 times 2. So negative 4 times 7 times 2. And then I have c to the 3 and a negative 2. So c to the 3 minus 2. And then I have d to the 2. Negative 4 times 7 is 28. Times 2 is 56. So I have a negative 56. C to the 3 minus 2. That's just c to the 1. And then d to the 2. And I don't have to write that 1. So I'm going to just write it like this. Negative 56 c d squared. All right, so now we're going to do some scientific notation. We touched a little bit on this at the beginning of the video. What we have here is, in chemistry, at 20 degrees Celsius, 1 cubic meter of water has a mass of about 9.98 times 10, I think that's a 5 grams, so I think it's 10 to the 5 grams. And then each gram of water contains 3.34 times 10 to the 22 molecules. About how many molecules of water does the droplet of water shown below contain? And I'm told that this droplet of water, I'm already given its volume, and its volume is 1.13 times 10 to the minus 7. And I want to take that volume of water and I want to multiply it by the number of molecules. So I have a cubic meter has a mass of 9.98 times 10 to the 5 grams. So I have 1.13 times 10 to the negative 7 cubic meters. That's a volume. And I'm told that each cubic meter has 9.98 times 10 to the 5th grams. Okay. And I know that each gram of water has, get this, 3.34 times 10 to the 22 molecules. So if I'm going to get the molecules of this drop of water, I need to multiply its volume by its grams and then by the number of molecules. So this is scientific notation, but it works just the same. So I'm going to multiply my numbers together. So I have 1.13 times 9.98 times 3.34, and we have a whole bunch of decimals here, but that's okay. And then I multiply that by times 10 to the negative 7 times 10 to the 5 times 10 to the 22. Okay, so let's multiply our numbers. 1.13 times 9.98 times 3.34, and I get 37.7. I'm rounding. And then here's some of these exponents. The bases are all the same. So I'm going to do times 10 to the negative 7 plus 5 plus 22. So now let's figure out what that exponent should be. So I have 37.7 times 10, negative 7 plus 5 plus 22 gives me 20. Now scientific notation has a rule, and the rule is that we don't have two numbers to the left of the decimal point. It has to be a number between 0 and 9.999, whatever. So I need to take this decimal point and I need to slide it over that way. Okay? And when I do that, I'm actually dividing that number by 10. So instead of 37.7, I have 3.77. And since I divided by 10, I have to multiply by 10 over here, or else I've changed my number. There's an invisible 1 here, so this is going to be times 10, add my exponents to the 21. And that is my answer. So just as a quick summary here, if you're going to multiply powers to the same base, add the exponents. And they did some examples here, like look at this one. We have, oh, this is hard to read, but we have 4 to the 1/4 plus 4 to the 3/4. And I can add those exponents together, so I get 4 to the 1/4 plus 3/4, and that gives me 4 to the 1, or just 4. All right, that's it, everybody, for today. Thank you for watching. Have a fantastic day.